Hello trade class. This video is made for the evening of October 5th, which is a Monday, and I'm wondering, how are you? The secret to why I'm saying that will be revealed in a bit. Before we enter into graphing secants and cosecant curves, I found an interesting picture of where the tangent curve is observed in nature. So let me get it in the screen here. So whoops. All right, how cool is that? That is an interesting place where God has displayed the tangent curve in nature. Would you like to know where that forest is? Field trip. Take 3 guesses and write them in your comp book of what country these trees are found in. So here's the tangent curve right here, like that. Very good. And today in class we learned the cotangent curve, so let me find one of those for you. It's not as cool of a picture of that. I'm not seeming to find it right now. I would try to turn this upside down, but I have that rotating screen that won't do that. Alright, I don't know why I can't find it. Anyway, not to waste any more of your time waiting, I'll show you the picture of the cotangent in nature another time. Today, our attention is secant and cosecant curves, and we'll see what that has to do with you. All right. Graphing y equals secant x. Take notes in your comp book, and you can add this definition or this line to your table of contents and put in the next number of pages. I'm not sure what that is, but we'll look at that in class sometime to make sure we're all on the same page. Haha. Alright, so the key to graphing the secant curve is remembering that secant is equal to 1 over cosine x. So with that, recall wherever this is 0, right here, it creates a 1 divided by 0, which cannot exist. So secant cannot exist wherever the cosine is 0. So my first step to graphing the secant is graphing the cosine. In order to do that, I am going to put these on the same graph. Say this goes up to 1 and down to -1, and cosine starts at the top. Here's my tick marks, 2 pi, pi, and pi over 2, and this one was 3 pi over 2. So you call cosine starts at the top, comes down, bottoms out, comes back up, and goes like that. Actually, I wanted to draw that lighter, so I guess I'll just try to lighten it up and make the next one even darker. And that'll go on this side as well, where we hit negative pi over 2. So here's where the value of the regular cosine curve is 0. So, and at those spots, secant cannot exist. So we put in our asymptotes wherever that happens. Now it turns out that the secant curve, being the reciprocal of the cosine, is sort of the upside down version of this. So it's going to include that point, and it won't touch these asymptotes, but it has a U shape. Do you see it has a U shape? There's the U shape. Trying to make it darker, but I'm going to bore through my table here. Alright, here, and then down here it comes up like this. So in a U shape, and then it would go and continue in the like manner on both directions. So that is the beautiful secant curve. And I was wondering, is it even or odd? So if I go out x, remember looking at even or odd, we want to know if secant x is equal, question mark, to secant of minus x. I want to see if they're equal or if I have to make one side negative. So if I go out x, say I call this x, then to evaluate the function at x, I go up and hit this value and read it right here. So f of x is that number. If I go out in the equal distance in the negative direction, negative x, f of negative x, I go up here and hit the same spot. So this is also f of negative x. So it turns out that they're both equal, no question about it, and that means this is an even function. So that is our next trig ID. Secant of x equals secant of negative x, and I'm not sure what number, somewhere around 22 or something, you know. All right, so I was wondering, and I'm sure you were, as well, as what is the period for this secant curve? This normal secant curve has a period of, well, we want to start, say, here, and where does that go until it starts repeating itself? Right there. It starts again. So from here to here. So that marks this and this. How long is that from here, where we started counting, to here, where we end it? Well, this value right here is 3 pi over 2 from the origin. And this value here is pi over 2 from the origin. So from here to here, thinking positive numbers, we have pi over 2 plus 3 pi over 2, which is 4 pi over 2, or 2 pi. So the period for the normal secant curve is 2 pi, and it's an even function. All right, how would you graph y equals 2 secant x? In order to do that, you will have to graph y equals 2 cosine of x, and then fill in the opposing u's. So, all right, so we're going to put in we're going to graph this one, and all this is cosine with amplitude change of 2. So instead of going up and down to 1 and negative 1, it's going to go up and down from 2 to negative 2. Same tick marks as before. So nothing has changed but the amplitude on this problem. So when we have that going on, we have, I'll take this over to here, these asymptotes again, which is negative pi over 2, pi over 2, 3 pi over 2. So the u's go like that, and like that. So the really only difference is how far this u comes down. It only comes down to 2, and the regular one it came down to 1 on the y-axis. And the y value here goes up to negative 2 instead of up to negative 1. So that's what it looks like when we put it 2 in front of the secant curve. So it's easy to find when you use the cosine curve. All right, I'm not sure how long I've talked, so I'm going to show the next example in the next section. I didn't bring my timer. So see you in a minute.